Hi everyone. So today I was going to talk a little bit about the bottom. Sort of a passion of mine, I guess, is mud, and much of this work has been done by undergraduate student of ours, Sophie, and also Craig Hetherington has been doing his PhD on this. Now Simon and I have had a passion for the passage for many years now. I think one of the things that's really cool about it is that you have this sort of compressed catchment to a tidal sort of braided channel network, and then on the ocean side you have this wave interaction, and that's a really, I guess, as well as being an aesthetically pleasing spot, it's really interesting from a coastal science point of view. Sorry, next slide. Thanks. Oh. So I guess a lot of this work has been, the sediment work has been through the Port of Brisbane and Healthy Land and Water and doing our sediment surveys. What kind of kicked this off was trying to think about some of the impacts of the floods that have been coming into the broader bay. So in 2015, we did one of the kind of bay-wide surveys. So this is, I guess, 225 sites all the way from the Gold Coast up to top of the Pumicestone. And when you compare that, I guess, to the 1970, the sort of Maxwell studies from the 60s and 70s, the amount of mud in the bay, I guess, increased from sort of 400 square kilometres in 2015, and it was over 860 square kilometres. So you kind of stood back and thought, wow, this is, we might have missed something here. And so if we zoom in, I guess, on the passage, sorry, next slide, thanks. And I guess the granularity when you're trying to look at systems as complex as the passage, you shouldn't read it too much into individual sites. I think the broad patterns are kind of more informative. There's kind of this compression of sediment types, particularly in tidal channels, where you sometimes have kind of mud in the intertidal and kind of a sandy bottom all over 10 meters. So yeah, I think today I'm going to focus a little bit more on the kind of broad spatial patterns. But there are, I guess, sort of two areas that we've sort of looked at. Could just step back. One more, sorry. Yeah, thanks. So then Sophie came back and resurveyed 3 years later, and I guess she did a far better job than we did. But there's sort of these zones in the Bight and just upstream of Coochen, where you have sort of regular large deposits of mud farm. If we just go forward one, thanks. I guess with the passage, one thing to bear in mind is that sediments is always driven by hydrodynamics. And so if you have these areas of high flushing and high energy, it's very difficult for any settling of mud to occur. So in kind of the northern part there, if you look at some of the features along the bottom, obviously much cleaner sand and these big ripples that obviously indicate huge amounts of energy coming through there. If you go, just click one forward, please. Oh, sorry. Thanks. Okay, that's a bit better. And then you get these depositional features as well in there. And so that certainly is one of the areas that's kind of regularly muddy when we go and visit it. We've done it a few more times, actually. So where does, I guess, the mud come from? This is just a sat image of the passage. And so I guess is kind of how we normally see it, relatively clean conditions, but it's certainly not always like that. And so this is one of the events that have coming through into the passage. And if you zoom in, I guess, on Coochen, then you can sort of see, I guess, there we go. So these sort of areas here is where, I guess, some of the dilution of the flood plume has come in. So you really kind of, I guess, Coochen is certainly an important area for the mud deposition within the passage. Hopefully this works. Now it is fairly regular, these sorts of things. So one of the things when you interrogate the satellite record is you need cloud-free days, but pretty much with the kitchen, with the Durham monitoring station there, when you get flood events coming through there, fairly regular intervals, you're getting this massive injection of sediments kind of into that null point that Mike was talking about earlier. So obviously tidally, that's where there's a small amount of energy, but when you have the large flow events come through, then you can start to move a lot of material in there. And now, I guess this is in light of the oyster shellfish presentations, this I guess will be relevant, but just north of there, we put in some ADCP, so a current monitoring system in there, and logged the bottom. And so this is, I guess, just to illustrate the value, I think, in the flushing mechanisms that happen in the tidal areas. So once this material gets deposited into the passage, it just doesn't stay there. So you can, I guess, get moved around. And this is the water level. So as we moved in from a spring tide to a neap tide, then if you log the turbidity, which is an indication, I guess, of how much sediment is in the water. One of the things with sediment transport, it happens along the bottom meter. So even if you're monitoring your surface waters regularly and everything, you might be missing a fairly big story in terms of how much is changing along the bottom. But one of the, I guess, obvious things from this is that it's a highly tidal movement of material that happens through the bed there. And I guess what Susie was mentioning about the collection of fine materials that was deposited in this area. Yeah, I mean, that's what's happening all the time. So we have these big events coming in, and that's driven by the current speeds, so 0.9 meters per second, sort of roaring through these on a spring tide. So that's able to move a lot of material up and down the system. And I think it's important to step back and take a look at how these things are changing over time. And sometimes when you do like relatively short, sort of 3-year projects, you sometimes lose focus of kind of the overall pattern that's going on. And I guess we're lucky in the case with the passage, as there were some previous surveys that were undertaken through there in the 70s, or late 70s, early 80s, and then again in the early 90s. Now, yeah, I mean, the trend is obvious, but one thing I think to bear in mind is that you now have this sort of regular detection of this kind of above 50% mud that's happening in there. And this is, I guess, impacts the quality of the substrate a lot. So along with the transition from sand to mud, you go from a relatively benign kind of silica-based system. When you start to put in lots of mud into a system, what comes with that mud is particularly heavy metals. So iron and manganese are sort of highly reactive for microbial processing. You have a lot of organic matter that comes in with these systems, and obviously high nutrient loads. So I guess the sort of way that I look at it is that the sediments are kind of the memory of the system. So you have these deposition events that come through. They might look like dirty water for a while, but the sediments kind of always remember what's going on with these systems. So we're sort of performing this massive biogeochemical experiment. And it's not only in the passage, it's happening in the bay as well. And so if you look at, I guess, focus in on the bite, which is right bang smack in that null point, then you take a sediment core through that, you can sort of see this transition happening. So if we go from the bottom of the core, this is about 40 centimeters down, and you look at the particle size, that sort of line there, hopefully I got close to that, that's sort of the sand fractions that you get in there. And then as you shift from the 40 centimeter core up to the surface, you see this obvious shift from kind of sand-dominated systems into the mud-dominated systems that we have at the moment. This is going to take a long time to shift out of there. I mean, there's very little tidal action that goes on in there, and every time you have a flow event that comes in, you're going to deposit more and more material in on that. It's not, I guess you always try and look for positives in this, but I guess in some of the work that we've done, kind of broadly across the bay, there's certainly parts of the bay. If you go to the southern area, and you compare, I guess, looking at the aerial record, some of the changes that we're seeing in the islands down there. I think this is Short Island. It's sort of on the order of 80 meters that's been eaten in 10 years. So you're seeing a big change in, I guess, the whole overall kind of island patterns down there. One thing when you are putting lots and lots of sediment into a system is that you can kind of negate some of the, I guess, some of the challenges that we're going to see from sea level rise and coastal erosion. So this is in the passage, and you get very little change, I guess, in the creek mouths there. So you are able, I guess, at some level to stabilise the impacts. So yeah, I guess there's a kind of structural component as well as this kind of biogeochemical influence. If you look along the bottom, this is, I guess, particularly in the northern parts, you start to get some interesting changes in the bare sediment side. So this is at Bells Creek mouth, and if we just look at, I guess, the line along there in the 10 years, you get this kind of big shrinking that's going on. So a lot of the kind of the whole passage kind of sediments are starting to shift down the sand at least. So I guess indicating some interesting changes in the hydrodynamics there, as well as this kind of mud that's starting to shift north. But I guess we're going to learn about the breakthrough sooner, but I think one thing to consider with that is that the passage is going to experience sort of dramatic changes in its hydrodynamics as you start to bring water in from different parts of the passage. Oh, thanks. Sorry, it was supposed to be a video at the end. So yeah, I think that's something to bear in mind, that what's happening at the moment is uncertain. So yeah, you can plan a long time into the future, particularly around coastal erosion systems, but they change. They can change with the changing hydrodynamics. Yeah, thanks very much.
We do have one question while the next presenters come up and start getting ready. What are the sediments? Are they topsoil, subsoils, clays? What are they comprised of?
Yeah, no, that's a very interesting question. I guess one of the things to bear in mind with particularly southeast Queensland is that a lot of it's driven by channel erosion. So as we've removed riparian sort of vegetation from the systems, we've changed from these gently sloping kind of channels, and we've now made them much steeper. And so what that does is it channels the energy into the channel now. And so I guess a lot of what we're seeing in what's coming into our receiving water bodies is from the actual channel itself. And so you're able to load a lot more sediment in when you do that. So sheet erosion, it's quite difficult to get huge amounts of material in there. But if you're eroding the creek wall itself, then it's just purely a function, I guess, of how much water is moving through the system. So I think, yeah, mainly it's from the creeks themselves.